Welcome to Selection Sathi. Today we learn C++ object-oriented programming, classes, constructors, inheritance, and virtual functions. OP is the paradigm that makes C++ powerful for building large-scale software. These concepts are fundamental for gate, interviews, and real-world development. Let's begin. First concept: classes with public and private access. A class in C++ encapsulates data and functions into a single unit. Members declared as private can only be accessed within the class itself. This is the default. Public members can be accessed from anywhere outside the class. Protected members are like private, but they are also accessible in derived classes. The key idea is encapsulation, hiding internal data and exposing only a clean interface. Fun fact: the only difference between class and struct in C++ is that class defaults to private access, while struct defaults to public. Second concept: constructors and destructors. A constructor has the same name as the class and no return type. It is called automatically when an object is created. The default constructor takes no parameters. A parameterized constructor takes arguments to initialize members. The copy constructor takes a const reference to the same class type and creates a copy. The destructor has a tilde before the class name. It is called when the object goes out of scope. Use the initializer list syntax, member parentheses value instead of assigning in the body. It's more efficient and is required for const members and reference members. Third concept: virtual functions and the vtable. The virtual keyword enables runtime polymorphism. Without virtual, when you call a function through a base class pointer, the base class version is always called. With virtual, the compiler creates a virtual table, or vtable, that maps each virtual function to the correct version. At runtime, the program looks up the vtable and calls the right function based on the actual object type. A pure virtual function has equals 0 at the end. This makes the class abstract. You cannot create objects of an abstract class. It serves as an interface that derived classes must implement. Fourth concept: inheritance. Inheritance lets a derived class inherit members and methods from a base class. This is code reuse. With public inheritance, public members stay public and protected stay protected in the derived class. C++ supports multiple inheritance. A class can inherit from more than one base class. But this can cause the diamond problem. If two base classes share a common grandparent, the derived class gets two copies of the grandparent's members. The solution is virtual inheritance, class B: virtual public A, which ensures only one copy. First example: rectangle class with constructor. We define class rectangle with private members W and H for width and height. The constructor takes two doubles and uses an initializer list W of W, H of H. The area method returns W times H. We create an object rectangle R of 5, 3. R.area returns 15. The constructor initializes the object and the method computes the result. Second example: inheritance hierarchy. Shape is the base class with a pure virtual function area returning double. Circle derives from shape and implements area as 3.14 times r squared. Rectangle derives from shape and implements area as W times H. The power of polymorphism, shape star S equals new circle of 5. When we call S arrow area, it calls circles area method, not shapes. This is runtime polymorphism enabled by the virtual keyword. Third example, virtual function override. Animal is the base class with a virtual speak method that prints ... Dog overrides speak to print woof. Notice the override keyword. We create animal star a equals new dog. When we call a arrow speak, the output is woof, not ... Without the virtual keyword, the compiler would use static binding and call animals speak. With virtual, it uses dynamic binding and calls dogs speak. That's the key difference. Fourth example, abstract class with pure virtual. Shape has a pure virtual function, virtual double area equals 0. This makes shape abstract. You cannot create a shape object directly. Circle derives from shape and provides a concrete implementation of area. Now we can write circle C of 5, then shape star S equals ampersand C, S arrow area calls circles area. Abstract classes define the interface, what functions must exist. Derived classes provide the implementation, how those functions work. Quick tips. Tip 1. The only difference between class and struct in C++ is default access, class is private, struct is public. Tip 2. Use initializer lists in constructors, they're more efficient and required for const and reference members. Tip 3. Always use the override keyword when overriding virtual functions, it catches typos at compile time. Tip 4. If a class has virtual functions, make the destructor virtual too, otherwise deleting through a base pointer causes memory leaks. For more concept videos like this, download the Selection Sathi app. Like and subscribe. Thank you.